Hello everyone and welcome back. We're now on example 9-7. Working through these quickly. So, this one has a lot going on, so let's talk about it first. I'll actually read through the problem statement and then we'll get started. So this one it says we have a 25mm diameter bolt, which extends vertically through a timber beam. The maximum tensile stress developed in the bolt is 83 megapascals. Okay, so this time we're given the stress. It says determine the minimum required diameter for a circular steel plate that's to be placed under the head of the bolt. The bearing stress on the timber is not to exceed 3.4 megapascals. Okay, so we're given two stresses here this time. So it might seem confusing to you, but let's draw it out and it'll make a little bit more sense. So what I have here is I have a bolt that is going through a timber beam. And that is going to be pressing on some washer. Now the bolt has a load on it. We don't know what that load is. We'll have to calculate that. And the bolt is said to be 25 millimeters in diameter. That little symbol right there means diameter. We want to know what is the diameter of this plate. Well, we're told that the minimum stress, or the maximum stress they can have on the wood is 3.4 megapascals. At that point, it's probably going to start caving in the wood and damaging it, or just pop straight through. And that the stress in our bolt is equal to 83 megapascals. Now, one thing to note is that the load is going to be shared by both of these points. This washer is going to feel the same load as this bolt. We're going to use that to solve our problem. So let's write down stuff that we have. We're given that the stress in the bolt is equal to 83 megapascals. That the stress in the wood, the bearing stress on it, can't be more than 3.4 megapascals. We're given the diameter of the bolt, which is 25 millimeters. And we want to find what is the diameter of the washer that can make all this work. That's what we're going to solve. So first off, let's just blindly start deriving equations. I'm going to write my stress equation. Stress equals load over area. I don't know the area of the washer, but I can probably figure out the area of the bolt, because that bolt is circular, and therefore we know the area is going to be equal to pi over 4 d squared. And that's going to come out to be 491 millimeters squared. Okay, so with that, I know the stress and I know the area of the bolt, so I should be able to calculate the load. So I'm going to rearrange. I'm going to solve for the load first. It's going to be equal to stress times the area. I'm going to multiply it out. So it means it's equal to 83 megapascals times 491 millimeters squared. Now, if you don't remember what the units are here, you don't know what they are, just remember that 1 megapascal is equal to 1 Newton per millimeter squared. I've got millimeters squared here. I've got megapascals. So the unit should be newtons. And if I solve this, I get that the load is going to be 40,753 newtons. Okay, so far so good. So now I know what my load is. Now I still need to find that diameter for that, the diameter for the for the washer, because we don't know what that is yet. But the equation is the exact same. Sigma equals load over area. So if I solve this for the area this time, multiply both sides by area and divide by the stress, I get that the area should be equal to the load divided by the stress, which is going to be equal to 40,753 newtons, all divided by 3.4 megapascals. And if I calculate that, it comes out to be 11,986 millimeters squared. Now, this is a circular washer. this is a circular washer, which is what we're going to need to do to figure out what's going on with this. Other thing we should think about is that there is a hole for the bolt to pass through. This washer is not one perfectly flat plate, it's got a hole in it. So I'm going to go ahead and erase the picture I have right here and draw a different one of just the bolt and just the washer. So I have a hole through the center, which has to be big enough for my bolt. My bolt is 25 millimeters in diameter, 25 millimeters. I'm trying to find the size of this, which will be the diameter. So what I get is that the area, 11,986 millimeters squared, must be equal to pi over 4 d squared minus pi over 4 times 25 squared. And if I then solve for this, what I get is that the diameter is going to be equal to 126 millimeters, which is around about 5 inches wide. That's a big washer. It's a big washer. But if you think about it, the bolt itself was an inch thick, so it makes sense. Okay, with that we've solved. So sometimes you're going to have these two-step problems. You're going to have to use what you know from one step to plug into the second step. Subscripts are super important in this, like the sigma bolt, sigma wood, sigma being this symbol right here. Make sure you write those out because that can help you keep from getting confused. I'm kind of used to this, but I should have probably written sigma bolt right here and wood right here to make sure that it was completely clear which was which from the beginning. So with that, I hope this helps you. Just remember that you have, each time you're looking for a stress in a different member, if they're all connected, they probably have the same load going through them. That's not always true, but they probably have the same load going through them. And then if you can figure out their respective areas, you can figure out the stress. So I hope this helped you, and I'll see you in the next example. Have a good day.